Swayam Prabha. Digital India. Educated India.
Welcome back. In Module 4, we will talk about waste generation, storage and minimization. And in Lecture 16, we will start with waste generation. The different concepts that we will cover is on municipal solid waste generation. Waste generation, we will give a global outlook, key drivers for municipal solid waste generation, and projections, how to project municipal solid waste generation. So, when we talk about municipal solid waste generation, there are usually two aspects that needs to be considered. One is what sort of waste we are considering within the municipal waste stream, and as you know that we have earlier discussed that certain kinds of waste like the construction and demolition waste or hazardous waste, this could be kept out of consideration, whereas we are mostly concerned with the organic waste, the combustible waste, the non-combustible waste, and the different other fractions of waste from where we can recover some amount of recyclable materials, and the inert waste like we gather from street sweeping or cleaning of drains and so on. So this is in general, this is what municipal waste is all about. And when we talk about municipal per capita waste generation rate, this is usually what we are referring to. Now, when we talk about this municipal solid waste, there are again two parts to it. One is how much it is generated in an urban area and how much it is collected in an urban area. So, sometimes the figures that we get from literature or from documents is there is a overlap between these two. Sometimes it is as per the amount of waste generated by different households, or sometimes it is as per what is recorded, and usually that is based on the amount of municipal waste which is collected. So, in many cities, there is a significant difference between amount of municipal waste which is generated and amount of municipal waste collected. But anyway, we will try to sort those values as we go along, and then you can understand the difference between what is the amount which is generated and what is the amount which is collected. So, municipal solid waste, it's a natural product of urbanization. So, with more urbanization, more amount of waste would be generated. And usually the amount of waste that is generated in urban areas is much higher than what is the amount of waste generated in rural areas. There are two reasons, there are many reasons for it, but the primary reason being the consumption pattern is different in urban and rural areas, and there is a significant amount of reuse in the rural areas. For example, organic waste and even lot of liquid waste gets reused in the form of fertilizer for the urban fields and all, which is sometimes not possible or which is sometimes not practiced in urban areas. So, there is significant difference in the amount of waste which is finally generated or which comes to the waste stream outside. So, municipal solid waste, it's a product of urbanization mostly because we are dealing with municipalities, and it depends on population of that particular urban area. It depends on the demographic characteristics of that population, the type of city it is, the nature of city. For example, if it's a large city, then it will have, in addition to a lot of residences, it will have a lot of commercial areas, institutional areas and so on. Whereas in case of a small city, there may be some commercial area, but there may not be too much of institutions and other kinds of industries and so on. So, these are the difference in the city's characteristics or city's nature. Then the income levels of the population. So, one is the demographic pattern, socio-economic characteristics, but within that we can also talk about the income variation among the population. So, the income levels, how, or if we talk in the terms of an urban area, how rich that urban area is, right? Overall, the affluence in that urban area, and the lifestyle of the people. That means it depends as per different cultures, as per different society, as per affluence, the lifestyle of people also changes. So, different lifestyles, different income levels leads to different quantity of waste that is being produced in urban areas. So, why this happens? Because income is related with consumption. That is, with more income, usually you consume more. It's not always the case, but usually higher income countries or higher income households usually tend to consume more, and if you consume more, automatically you will generate more waste. Now, how we can determine the income or change in income? So, in that case, the GDP growth is an indicator of change in income. That means with GDP growth, income level of the country also changes. We will explain that in detail later. So, that means if I can predict the GDP of a country, automatically we would be able to determine what sort of increase in waste generation will also happen. For different income groups, waste quantity and composition also changes. Now, why it is so? Because we have already said that as per demographic characteristics, as per income levels, the total amount of waste that is generated changes. But the composition also changes. Why? Because of the change in the lifestyle. Different people with different levels of affluence consume different kinds of good. So, automatically the waste that is generated is of different nature. For example, if you can afford, you will buy, a poor household will probably not buy packaged food, whereas a rich household usually buy a lot of packaged food, or they will order a lot from the restaurants. So, that will generate a lot of plastic waste. So, that's how composition of waste also changes as per the affluence or the lifestyle of the people. So, usually, so these are the basic fundamental characteristics of waste generation rates in urban area, you can say. And usually we say that in a particular urban area, we have to assume certain growth rates for both the growth in population, growth in the amount of waste that is generated, so that we can project the waste generated in future. So, CPHEO manual suggests us some figures. For example, per capita waste generation increases around 1.3% per year. That means, because we can assume that households grow in sizes, households income changes. So, with a change in income, change in lifestyle, gradually there will be increase in the amount of waste that is generated by the household. So, that is considered as around 1.3% per year. Then one part is the urban waste generation rate, per capita waste generation rate. The other is how much is the urban population change, that is because total quantity of waste depends on the total population multiplied by the waste generation rate. So, urban population growth rate is around 3 to 3.5% per year approximately, considering Indian conditions, right? But it's not necessary that this would be true for most urban areas, neither it is necessarily be true for different urban areas in different countries. In some places, the urban areas also shrink. So, we have to be careful about these values. So, overall, if I say in case of an urban area, overall waste quantity increases by 5% per year. And not only that, not only number of people change in an urban area, sometimes what happens, the urban area also grow in size physically. That means the jurisdiction or the boundary of the urban area is extended. So, in that case, the ULB size will also change. So, the municipal body's boundary will also change, and that also leads to change in the total waste that the municipal body has to handle. So, municipal solid waste is a function of population, the rate of waste generation, and also the size of that urban area. Now, the National Environmental Research Institute in the year of 1996 conducted a study on 43 cities, and they found that in Indian cities, roughly the composition of waste, that is, what is the type of material that is available inside the municipal waste stream, they found that organic fraction is around 30 to 40%. So, that is biodegradable fraction is around 30 to 40%. Whereas ash and fine art, these are mostly inert material and all, comes to around 30 to 40%. And finally, the rest, paper comes to around 3 to 6%, and plastic, glass and metal each is around 1%. Now, you can see that means all these are more or less recyclable materials. So, around 6-7% of recyclable materials is generated. Now, the problem is, even though it is generated, municipalities in many cases don't end up collecting this. Why? Because sometimes people do sell this directly to some informal groups, informal waste collector groups who sell them via the covered system to the different or the recyclers, to the local level recyclers, and so that doesn't enters into the municipal stream directly, but it is generated at the household level, but at the collection level it doesn't reaches the collection part. So that also needs to be considered. Similarly, calorific value of refuse was found to be around 800 to 1000 kilocalories per kilogram. So calorific value is important, as we have discussed earlier, that this determines if the waste can be incinerated or not, or is it feasible to consider incineration as a disposal mechanism or final treatment mechanism for this kind of waste. And also the carbon to nitrogen ratio in waste was found to be around in the range of 1:20 and to 1:30. Now, carbon to nitrogen is actually the content of carbon matter and nitrogen matter, nitrogen mass and carbon mass in the organic waste stream. Now, why it is important? It is important for the success of the composting process. So, there are some ratios which are ideal for the composting process. We will discuss that in detail when we do composting. So, now what we have discussed is, as per the nature of the city also, the amount of waste that is generated also changes. Over here you can see in this table, cities with different population ranges. This is again data from 1996. It was found that with smaller cities where population range is around 0.1 to 0.5 million, so in that case the rate of waste generation was found to be around 0.2 kilograms per capita per day. Whereas for cities which are larger size, around more than 50 lakhs, so in that case the waste generated was found to be around 50 kilograms per capita per day. This doesn't mean that everybody in the city produces this amount of waste. What it means is that average of waste that is generated in a city of this size, which includes residential area, commercial area, institutional areas, and all the different kinds of generators, both small generators and bulk generators, all things included, this is the average value of waste that is being generated. Now, CPCB conducted another study during the year 1999 to 2000, and they found that and they did study on 210 class 1 cities and 113 class 2 towns. So, class 1 cities are small cities, class 2 towns are even smaller cities. So, roughly 1 lakh population and even lesser than 1 lakh, 50,000 to 1 lakh for class 2. So, in that case, you can see that they found that in class 1 cities, the value of waste generated is 0.34 kg per capita. So, if I put it in this particular table, class 1 cities roughly comes around somewhere in between these two. So, we can say that the value was around 3.4, whereas class 2 cities comes somewhere between here or maybe somewhere in between here, right? So, it was coming around 1.4. So, which was a little bit lesser compared to what the previous study has found. But anyway, so that what it means is waste generation varies as per different cities. It also varies for many other purposes. So, we have to be very careful about this particular rates. Why? Because when you multiply this by the total number of population, we and also multiply it with the number of days in the year, you get a huge amount that has to be dealt with, right? The waste. So, in that case, if I am not careful with these rates, you will end up with designing facilities which are either over designed or under designed. So, that's the reason we have to be very, very careful about these values. So, in subsequently, NARI in the year 2004 and 2005, they again conducted another study on 59 cities, including 35 metro cities and 24 state capitals. They found the waste generation rate varies from 0.12 to 0.60 kg per capita per day. So, you can see the difference in the change in the waste generation rate in different cities, and these are done mostly in the major cities, right? Either 35 metro cities as well as state capitals. So, even in the large cities, we can see the difference ranging from 0.1 to 0.6 kg per capita per day. So, just adopting a value like 0.5 or 0.35 for a city without doing any kind of surveys, doing any kind of check will result in wrong estimates for the entire solid waste management plan. So similarly, in terms of composition, what they found was compostable matter was 40 to 60%. So this value is more than what we found earlier, which was roughly 30 to 40%. So now we found it to be much more. Then recyclable fraction also increased to 10 to 25%. The moisture content of the waste was found to be around 30 to 60%. So this was not found earlier, but now it was found that out of the overall weight of the waste, that 30 to 60% is moisture. This is also very important because when you are carrying this weight will matter in the transportation system that you will design. CN ratio was found to be more or less same, 1:20 to 1:40. So obviously this has increased a bit. So that means there is a lot of variety of the kind of organic waste that we are also getting. So this indicates that with more affluence in the Indian scenario, we are finding that more people are the percentage of compostable matter, the organic fraction is actually increasing in the West. And there is not, and the recycling fraction is also increasing. So, but in other developed nations and all, we have found that the compostable matter, organic matter is much less. Why? Because in India, the affluence level at the lower levels, usually we find that the consumption is very low. That because people are poor, they cannot, waste items or waste food. So organic waste is very less. But with affluence, the amount of organic waste increases. So that's what we are seeing. But again, when the income changes further, then instead of buying food from markets and cooking it daily, people will start buying packaged material and all, then it will again come down. So that means the composition wise, the organic matter increases gradually with the change in income and then again it falls back, right? Now, some other studies, this we can actually, in case of absence of data, absolutely no chance of doing any kind of service and all. So these are some of the values that you can adopt. For population above 10 lakhs for a city, we can go for 400 to 600 grams per capita per day. For population between 5 to 10 lakhs, 350 to 400 grams. And in small towns and cities below 22 lakhs, we can go for 200 to 300 grams per capita per day. To give you a comparison with other similar countries in the region or low or you can say emerging economies, this is data from the year 1996, we can see that the different income categories, low income countries which include Nepal, Bangladesh, India, China, Sri Lanka, these are all more or less South Asian countries, right? So here you see that the waste generation is more or less same with little bit increase for China and Sri Lanka. Now, why is that increase? You can see, now let us check the GNP per capita. This is gross national product per capita, right? So this is the indicator of the affluence of that particular country or society. So here you can see that Sri Lanka's GNP is higher than China's GNP in the year 1996. So accordingly, their waste generation rate is also higher. Now, India, Bangladesh, Nepal, there is some difference in the GNP, but in the waste generation levels, we are not finding so much amount of waste difference in waste generated. So these values can be considered in conjunction with GNP rate and all to make sense that what sort of affluence result in what kind of waste generation. So the other thing that plays a role is, of course, the urbanization rate. So we will talk about that in details. So you see the urbanization rate is also different for this particular countries. Over China, urbanization rate is a little bit higher than India. In 1996, of course, now it is further different. Sri Lanka, it's little bit lower. So urbanization rate may also influence the overall waste generation rate for a particular city. So that we will check later on. So now, considering a global, the scenario, recent studies say that around 2.1 billion tons of waste is generated annually, and around 3.4 billion of waste would be generated by the year 2050. So that means this is the quantum of waste that we have to deal with together in the overall, world. And out of all this, 33% of waste is managed properly. That means it's managed in an environmentally safe way. Now, you can say that in developed countries or rich countries, probably this percent is something around 90%, whereas in poor countries, this value is something around 10%. So, there is a significant difference among the countries as well. Global average waste generation is 0.74 kg per person per day. It is higher than the Indian average. The range is from 0.11, you remember this 0.11, we saw it in in Indian study as well, to maximum value of 4.54 kg per capita per day. So, it's a huge amount of waste that a person generates per day. So, high income countries, we see that around 34% of all waste is overall in the world is generated in high income countries, whereas they have only 16% of the population. And waste generated in South Asia, particularly India, Pakistan, Sri Lanka, Nepal and all these countries, Bangladesh, there the waste generation is supposed to double by the year 2050. So, rich countries are probably the growth would not be that high, but in poor countries the growth is very, very high. And in our country, we estimate that roughly the total waste generated would be double by the year 2050. Now, unlike developed countries, waste collected in poor countries is low. For example, 48% in urban areas, that means out of all the waste generated, around 50% of the waste is collected in urban areas, and the rest 26% is for outside areas, that is areas outside the urban area, semi-rural areas, rural areas and so on. So, you can estimate that only 50% of waste is collected. So, where does the rest go? The rest goes to unauthorized dump sites, unauthorized, people throw garbage in the drains, people throw garbage in the streets, people throw garbage in open plots and so on. So, that is where all this waste end up with. That is why we see a lot of litter in Indian cities. So, if we can improve the waste collection process of the waste and we can reduce the generation as well as the waste collection process, so automatically we will not see so much litter in Indian cities. Now, let us look at some data. So, if I divide the world into different regions, starting with North America, one of the most affluent regions, Europe and Central Asia, Latin America, Middle East, North Africa, South Asia, this is where we are, East Asia and Pacific, Japan and other places, and then Africa. So, you see that North America, the average waste generated is 2.21, whereas the range starts from minimum of 2 kilograms approximately to around 4.5 kilograms. So, that's the range. In India, we are at average at around 0.5 kilograms per capita, whereas minimum is 0.17 and the maximum is 1.44. So, that's the difference in range of waste generation in different parts of India or for different groups of people, different population groups in India. So, similarly, you can see the values for the other countries, and obviously, it shows that the more affluent a country is, or it's not only a question of affluence, there are other things, lifestyle and a lot of other things, the culture, all these things plays a role. For example, Europe is equally or more or less similarly affluent as America, but the waste generation rate is less compared to US. Whereas, if you go to Japan and all, it's also the GDP rate is more or less, the per capita is more or less similar or a little less, but the waste generation rate is much significantly lower. So, let's take at some other data points. So, over here we see two graphs. One graph shows this waste generation per capita, kg per person per year, and on the other side we have GDP per capita. So, this GDP calculation is done on PPP terms, that is as per the parity terms, right. So, this GDP per capita is the amount of income for the country divided by the population. And when we plot the amount of waste that is generated, you can see this scatter plot. We can see that the poorest countries in Africa like Sierra Leone and all is somewhere around here, whereas Japan is somewhere over here. It's an affluent country, but still it's at a value of around 300-350 kg per person per year, right. So, that comes to around 1 kilograms per day roughly, or 0.9 kilograms per day. Norway Norwegian country is a little bit higher, they are more affluent, but still the amount of waste they generate is higher, but not that high. Whereas US, they are affluent than Japan, but less affluent than Norway, but they generate a lot of waste. Same happens in Hong Kong, New Zealand, Denmark, Switzerland and other places. So there is a trend, of course, but it doesn't mean that it is same for all countries, but roughly we can find a trend where we can say that, well, GDP per capita, in terms of purchasing power parity, it's similar. It's as per that is we can say that it increases with increase in GDP per capita, but at the same time it is not uniform for all countries, and our country somewhere is around over here. So that means we generate around 100, 120, 30 kilograms of waste per year. So the other way to look at it, of waste generation rate, is the urbanization rate. So we can say that waste generation is positively correlated with economic development from this particular graph, and growth rate slows at higher income level. We can see that the growth rate at higher, so with increase in the GDP growth rate, we are not seeing a similar increase in the waste generation rate. So the increase is, the growth rate slows at higher income level. So that means if I have a car, if I can plot this, so the growth rate is gradually coming down when GDP increases. So this is what economic growth. So this is one of the key drivers for municipal solid waste generation, and the other driver is the urbanization rate. Let us check the data on urbanization rate. So over you see that with different levels of urbanization, that is percentage of people living in urban areas. So we see that this is urbanization rate is in this direction. It is in percentage, 0 to 100%. So certain cities are very, very urbanized. Certain countries or certain regions are very, very urbanized. For example, North America region is very urbanized, around 80% urbanized, right? So same goes for Latin America. Then Middle East is over here. South Africa is somewhere around here, whereas Asia is even lower, somewhere around here. So there is difference in Asia, of course, South Asia, of course. Some are higher, some are lower than Africa, but overall we are somewhere around here. So you see that with lower urbanization rate, somehow there is also a trend which shows that with higher urbanization, the rate of waste generation per capita also changes. So that means that with increase in urbanization, more area is urban, automatically the waste generation rate is also different, right? Or it will increase, right? Because as we have discussed earlier, that rural areas, the waste generation is less compared to urban areas. Similarly, with GDP per capita increase, we will also see a higher this waste generation rate in those countries with higher GDP per capita. Now, how do I project the waste generated for coming years? That means today I know what is the waste generated, but in future, how do I do that? So to do that, we need to, total waste, we say that it's population, the total population for which we are estimating it, multiplied by the waste generation rate. So our job is to determine how the population changes over time and how the waste generation rate changes over time. So if I am predicting the waste generation for the year 2050, I have to first predict what would be the population in the year 2050. So we have already discussed how to project population and what are the factors that has to be considered while projecting population. So we should consider the migration to a particular city, we would consider the birth rate, death rate, and many other factors, right? Similarly, the waste generation rate also needs to be predicted. And in the last slide, we have already showed you that with GDP per capita increase, we can also see an increase in waste generation per capita. So that means if I can find a relationship with increase in GDP, how much of waste is generated, then automatically I can predict that by 2050 we can estimate based on other things what is the GDP of that particular country or GDP per capita for that country, and accordingly we can predict the waste generation rate. So over here you can see that a regression model has been performed, a curve fitting exercise has been undertaken, and this is the curve that is generated. So this curve is actually predicts the waste per capita. This is curve means it's an equation. So this equation actually predicts waste per capita based on log of GDP per capita. That means we take a log of GDP values per capita and we would be able to predict the waste generated per capita. So this is a regression which has been conducted by World Bank, and they have projected GDP for different countries accordingly. So over here you can see that 2016 average values are given for waste generation rate per capita, 2030 projected values are given, and then 2050 projected values are given. This is short-term projection, this is long-term projection. As you understand, short-term projections are more accurate, long-term projections are less accurate, because the more the time passes, there is other variabilities, lot of things can influence the prediction. So we can see that in sub-Saharan Africa, all the areas or all the zones of the world is growing, but particularly you see in South Asia from 0.52 we are supposed to grow to 0.62 by 2030 and around 80 grams per capita, 80 kilograms per capita per day, 0.8 kilograms per capita per day during the year 2050. And if you can see that for North America, the growth right now they are at 2.21 and they will probably become 2.5. And similarly, this has been predicted for different regions of the world. Now, that means using this equation, we can do this kind of prediction. So that means we have to generate this kind of equations for our country as well, or for different cities, or we can take the GDP of different urban areas and accordingly using that we can also do some predictions. Now, how do I predict? So we can conclude by saying that waste generation rate is a function of GDP per capita as per this particular regression. But we can also say that, as we have seen in the last slide, that it could be a function of urbanization as well, right? So it's a function of both urbanization rate and GDP. So I can have another regression where I can include also the urbanization values of different countries, and we can also do a more accurate prediction. So coming to within my country, how do I predict GDP changes in an urban area? So city level GDP is basically estimated as a share of the district level GDP, and usually the state directorates of economics and statistics in India estimates the state domestic product and the district domestic product. So once these two things are predicted, we can predict that what is the share of the GDP for this particular urban area that we are talking about, and from there, based on the prediction of this state district domestic product for future year, we can also predict the share of that for the city level for future years as well. Now, how is GDP predicted? There are different ways to predict GDP. There is income approach, production approach, expenditure approach. But in our country, in India, we usually follow the production approach and the expenditure approach. Now, production approach of GDP calculation means we have to add all the values of all economic activities in a particular area or in an urban area, in some particular territory. What are these economic activities? That means amount of production in different sectors, construction, transportation, and so on. So we have to add all the production that happens in each of this sector, how much income is, how much amount of production happens, and plus the sum of outputs, all this minus intermediate consumption. That is, what is the amount of resources required to do this kind of production. So that has to be taken out. Plus indirect taxes minus subsidies on products. So when we do this, that is total income generated from different products and total production of different products and all. So in monetary terms, how much amount value of products has been created. From there, we can actually predict the GDP. Similarly, we can also predict GDP using the expenditure approach, where we determine the final consumption expenditure for households, non-profit institutions, then the government, and along with that we add gross fixed capital formation, acquisition less disposal of valuables, changes in inventories which are already there, and exports and minus imports. So when all these are added, we can also predict the GDP following the expenditure approach. So usually this is not, urban planners don't need to do that, but there are departments which actually conduct this kind of experiments. So is this type of estimations, and as you can understand, this sort of calculations could be also done at the district level or the state level, or even for some matters, if for large urban areas, we can also do this kind of calculations. So from there we can estimate city level GDP, and how the city level GDP changes over time can give an indicator of how the waste generation rate will change over time. So GDP minus depreciation is the net domestic product of the country, which is actually what we consider. So these are some of the references you can consider. To conclude, MSW generation depends on urbanization, demographic characteristics, nature of the city, income levels and lifestyle of the people. And MSW generation is likely to double by 2050 in South Asia. Thank you.